We're going to start just a couple minutes early. Votes at 3:15, and so this will be similar to hearing that we had last week when we were under the similar circumstances with the FBI director. Good afternoon. I call this hearing to order. I'm pleased to be joined today by the acting ranking member of this subcommittee, Senator Schatz. Senator Schatz was I chaired a subcommittee that he was the ranking member of before I came here, and he's followed me in this capacity, and I look forward to working with you and your colleagues on this particular issue of commerce, justice, science, the National Aeronautics and Space Administration. Administrator, we're delighted to have you join us. I look forward to the conversation. In light of the time constraints, I'm going to forego an opening statement, and I now turn to the Senator from Hawaii, Senator Schatz.
Thank you, Mr. Chairman. It is good to be back with you. Chairman Moran, thank you, Administrator Bridenstine, for being here. I'd also ask to enter both my statement into the record and Ranking Member Shaheen's statement into the record.
Without objection.
Thank you, Chairman.
Administrator Bridenstine, we welcome your testimony. I think we have, while you may have been instructed to make it abbreviated, I think we're going to have time to hear from you, and I would encourage you to tell us what you'd like for us to know. And if we run into trouble, we'll try to work on cutting our questions short, which suggests you may want to go long.
Okay. Well, Mr. Chairman and Mr. Ranking Member, it's an honor to be here. I have, of course, submitted my written statement for the record. I know because of the time constraint that we're short on time, and I'd be happy to forego an opening statement and just say this, that I've been charged with leading one of the most storied agencies in the United States government. It's the honor of a lifetime. We have people doing very dangerous things even right now on the International Space Station and flying missions all over the world to deliver science and discovery, not only on behalf of this nation, but on behalf of the entire world. So it's an honor. I'm thrilled to be here, and I look forward to answering your questions.
Mr. Secretary, before we turn to questions, let me encourage you to tell us, as part of your statement, the vision, the direction of NASA as reflected by its budget priorities. Outline for us what you see happening based upon the request of you and the administration for appropriations from our subcommittee.
Yes, Mr. Chairman, you're aware of Space Policy Directive 1, which is from the President of the United States, directing us to return to the moon and do it in a way that is sustainable for the long term. We have had in the past a number of different efforts to get back to the moon since 1972. And in fact, we have been at the moon, and we still are at the moon with orbiters and other capabilities. This president has said that getting back to the moon with soft landings for the purpose of an eventual human return to the moon is the objective to establish American leadership, but also to develop science capabilities on the moon and utilize resources of the moon, which is a new direction for this country, and I think it's an important direction, as we utilize the resources of the moon to ultimately take us to Mars and beyond. So that's, I think, a big policy direction shift. But I also want to be really clear that we are still going to Mars as well. In fact, one of my first launches as the administrator was the InSight launch, which is a lander that right now is on its way to Mars. And we're looking forward to that, doing a soft landing on Mars around the Thanksgiving timeframe and delivering science for an eventual human trip to Mars. So we're doing both. We're going to the moon and we're going to Mars. But we're not taking our eyes off the so many other critical, important missions of NASA, to include Earth science, heliophysics, astrophysics, and planetary science with robotic landers and other things. So I would say one of the President's objectives, and we've seen this in the NASA Transition Authorization Act, is to seek constancy of purpose, so that as we go from one administration to the next, as we're doing these decadal kind of missions, that we are actually moving out and accomplishing similar objectives to the previous administration, but at the same time, small shifts here and there to reflect the priorities of this president.
Thank you very much, Administrator, and thank you for joining us. I think this is your debut appearance as the Administrator of NASA in front of our committee, maybe in front of any congressional committee.
Yes, sir.
And I welcome you to your new position, and I thank you for working to develop a good working relationship with this subcommittee as we try to pursue things that make sense from a budget point of view, but also advance a cause of science and space exploration. So thank you very much. Let me ask you about that balance. The committee our committee has consistently looked at various scientific decadal studies that help us guide us in making decisions in the process. Obviously, lots of budgetary pressures always on any agency, but including NASA. How do you plan to maintain a balance in the scientific portfolio between planetary missions, Earth science, biophysics, and astrophysics? How do you reach the conclusion as to what the right ratio is of where our resources ought to go and what the mission of NASA should be?
That's a great question, Chairman, and it's not an easy question to answer. We have, of course, at NASA, within the various divisions of the Science Mission Directorate, we have a lot of critically important science missions going forward from previous decadal surveys, as a matter of fact. And what happens is when we take on some of these really big projects, and I can give a few examples, but one example that's very salient right now is the James Webb Space Telescope. We take on a project like that, which is something NASA needs to do. We need to be at the very leading edge of technology. We need to be pushing the edge of the envelope all the time. But when we take on a big project like that with brand new technologies and brand new capabilities, we sometimes have overruns in schedule and in cost, and that starts to impact other parts of the Science Mission Directorate. So what we have to do going forward, as to your point, the balance that we need to have across the different divisions of the Science Mission Directorate, we need to look at historically how those kind of missions can sometimes potentially crowd out other missions and then build architectures that deliver that same civilization-changing science, but maybe do it in a way where there is less risk involved. So one way to do that would be to look more at missions that are, say, $200 million or less in life cycle costs. And instead of doing one flagship mission, divide it up among a number of different missions. Then if one gets behind schedule or over cost, it doesn't impact all of the other missions that are currently underway. So that's one way to develop architectures across the different divisions of the Science Mission Directorate that ultimately will not have such a massive impact on the balance of the portfolio within each one.
Perhaps more make a statement, but maybe there's a question in this as well. You and I visited in my office. One of the things that I think NASA provides that no other agency, no other federal program can do is to inspire people, and often, many times, often young people, young men and women, to aspire to study science and mathematics and engineering and space. I have this goal for my own state at home in Kansas that we determine ways to increase STEM education. We need an inspiration, something that captures people's minds and hearts, and NASA, in my view, like no other agency or program, can do so. We talked about the budget request when you and I visited in person, and it eliminates a significant portion of that STEM education role for NASA, something that I indicated to you I find objectionable. You explained to me how this can be addressed in other ways, but I would ask you, I guess, again, what is your vision and view for how NASA can help educate and inspire another generation of individuals interested in science, and in doing so, help our nation economically, advance technology, excuse me, and to make certain that we are at the forefront of all scientific and educational advancement globally. NASA, in my view, it has that mission.
Yes, Chairman Moran, and I could not agree with your assessment on the importance of education. I could not agree with you more. I will say this about my own life. I was a young boy in 6th grade, and I had the opportunity to go to a summer camp where I interacted with a wind tunnel for the first time. And I learned about Bernoulli's theory of flight and how it works. I spent a week playing with a wind tunnel and changing the shape of a wing and seeing how that affected lift and drag and those kind of things. That was when I think it was the summer before my 6th grade year. And that impacted my life in an amazing way. And from that point forward, I knew that when I grew up, I was going to be a pilot. It was just the way it was going to be. So I've had that personal experience myself. I can also tell you, as there was a time in my life when I was the director of the Tulsa Air and Space Museum, and I saw firsthand the impact that I had when I was a child. I saw that impact on other children as well, fundamentally changing the way they viewed themselves and what they wanted to be when they grew up and the things that they wanted to study. And I can tell you this, there is no agency in the federal government that can do what NASA can do when it comes to inspiration, as you have mentioned. And of course, I've spent time at your museum, the Cosmosphere in Kansas, Hutchinson, Kansas. Wonderful, wonderful place. And the scout troop that my son is a member of, we've gone up there and spent a weekend studying the history and the technology, the capabilities of NASA. I believe, as you believe, that's absolutely critical for our nation. And I will tell you this, the 2018 omnibus spending bill, which just got passed a few months ago, obviously funded the education budget of NASA. And your NASA right now is moving out to follow the requirements of that spending bill. It is also true that we've had to make difficult, decisions in times of challenging, financial times, and this is one area that of course, has been trimmed. What I will tell you is that NASA has, and I've been there for a month now. NASA has in its DNA education, going back to the very beginning, and it has in its DNA inspiration. Every day NASA is making historical achievements, and every day, whether we want to or not, we are inspiring children and changing lives. And I will tell you that we want to. We are committed to it. Going forward, each one of the mission directorates has the ability to affect education, apart from that particular budget line. And we will continue to do that. We have, in fact, just this week, we started an internship program with over 1,600 young folks that are coming to NASA to determine whether or not this is something they want to do for their futures. So we are committed to education. We are committed to inspiration. I believe in it 100%. And of course, NASA will do that regardless of that particular budget line.
Administrator, thank you. And I would point out that your budget was submitted prior to your confirmation, and your budget was submitted prior to the FY18 omnibus bill taking effect. So you start from a new plane. I do want to make sure that this is emphasized in our efforts. And thank you for mentioning the Cosmosphere, and I look forward to your return visit to Kansas. Now recognize the ranking member, Senator Schatz.
Thank you, Mr. Chairman. Administrator Bridenstine, thank you for being here. Do you believe that greenhouse gases are the primary cause of climate change?
Yes, the National Climate Assessment that includes NASA, and it includes the Department of Energy, and it includes NOAA, has clearly stated that it is extremely likely, is the language they use, it's extremely likely that human activity is the dominant cause of global warming, and I have no reason to doubt the science that comes from that.
Do you agree with the scientific consensus, which includes many NASA researchers, that the climate is changing and humans are the leading cause?
Yes.
Is it fair to call this an evolution of your views?
Yes.
do you commit to supporting the funding, independence, and integrity of climate science at NASA?
Without question.
Thank you, Administrator Bridenstine. You and I have had multiple conversations, both over the table, but since then, in person and on the phone, and I just want to recognize your evolution on this issue. I think it's essential for one of the premier science agencies of the federal government for you to abide by the science. I think it's especially important because, as you know, you're the first NASA administrator that was an elected official. You're also the first NASA administrator with an essentially partisan confirmation vote, and so we needed to move through this period of sort of ideological disagreement, political disagreement, and back to the point where the NASA administrator is a leader of a science agency, and you can't lead a science agency if you are not grounded by the science. I thank you for that. I don't think it's easy for you to come to that conclusion. But on the other hand, what I have seen from you and in my interactions with you, I have come to the conclusion that this is a true evolution, that you respect the people with whom you work, you respect the science, you want their respect, and there is no way to move forward if you're going to be undermining the science, and so I'm really pleased to see this change. I want to ask you about earth science. NASA observations in earth science support resource managers and policymakers. So I want to talk to you about the termination of the carbon monitoring grants that we've talked about, the $10 million worth of carbon monitoring grants. First of all, I object to the termination of those grants, but second of all, I understand that NASA does has numerous lines of efforts as it relates to carbon monitoring. So first, talk about the grants, and second, talk about your commitment to carbon monitoring and earth science generally.
Yes, Senator, when you think about the carbon cycle of the Earth, NASA has a number of different satellites currently that are taking into account how the Earth is changing and how our climate is changing and how carbon ultimately plays into that. We have, right now, we're spending over $100 million annually on measuring carbon, not only in the atmosphere, but on the surface of the Earth and in the oceans and other places. And that's a critical piece of our Earth Science Division within the Science Mission Directorate. The carbon monitoring system specifically was a grant program. It's $10 million every 3 years. About 8 months ago, we issued grants, and so those grants are going to go through the year 2020. And that program in the 2018 budget request was not put in the President's budget request, and it didn't receive a line item for in the appropriations process. I will tell you that NASA has a number of programs even going forward. The Orbital Carbon Observatory 2 is currently on orbit. The Orbiting Carbon Observatory 3 we're going to launch in January. GeoCarb is another satellite that we're developing and soon we'll be launching to monitor carbon. There's a satellite called EcoStress that does similar things. And then JEDI is another satellite that we're launching. So the bottom line, Senator, is your NASA is 100% committed to understanding the carbon cycle, which is an extremely high priority that comes from the decadal surveys of the National Academy of Sciences. And you have my commitment that we're going to follow the guidance of those decadal surveys for the purpose of keeping it, as you have said, apolitical, bipartisan, nonpartisan, because the science must not be partisan. NASA is not a regulating body. What we want to do is we want to get the science. We want to get the data, and we want to make sure that we provide that data and that science to decision makers who can ultimately make sure that we're doing the right things as a nation and leading the world. So you have my commitment that NASA will continue doing that kind of activity, and we are.
Thank you.
Senator Schlotz, thank you. Senator Capito.
Thank you, Mr. Chairman. Thank you, Mr. Administrator, for being here. I appreciate it. I know you waited a while to get here, so we're glad you're taking charge. I wanted to ask you, you and I talked about the IV&V facility in Fairmont. I wanted to know I know that you've been aware and are supportive of that. I wanted to know what you might envision for the future there, where the applications may be more beneficial to NASA, but also within the federal government, if you have any thoughts on that.
Yes, ma'am, that's a wonderful question. So the IV&V facility is currently partnering with a number of different agencies apart from NASA.
Right.
I can think of the Department of Energy, the Department of Homeland Security. Of course, we have some non-government partners as well. So we do utilize NASA's IV&V facility to do governmental things that are broader than what NASA itself does. Yeah. And we want to continue doing that. Mm-hmm. We believe that we are a national asset that can be utilized by a whole host of different government and non-government functions. We want to make sure that when we do that, though, we're not impacting, of course, NASA's mission. So right. That's, I think, an important thing that I want to make sure that we don't impact NASA's missions. But certainly, we see ourselves as a partner to the federal government at large.
Well, thank you. Thank you. Last week, NASA announced that a team from West Virginia University was selected to test their research in simulated microgravity at the Johnson Space Center. They'll be able to conduct their experiments in the pool where the astronauts train for their spacewalks. This is a unique and tremendous opportunity for our students, as you can imagine. And it's part of NASA's education program. So I continue to be frustrated that the administration continues to call for the elimination of NASA's Office of Education. So I would suggest maybe you rename it to be the Office of Inspiration, because you're inspiring through these educational opportunities the next generation of science, technology, and interest in space and lighting a fire among a lot of young people. Will you work with me to continue to emphasize the importance of inspiring that next generation? And I didn't know if you had any comments on the elimination of the Office of Education.
Yes, ma'am. We just had a long dialogue, and I know.
Sorry.
No, you're good. But so what's interesting is you mentioned renaming it the Office of Inspiration, and we've been moving that direction at the NASA headquarters, but calling it the Office of STEM Engagement. I think when we call it the Office of Education, people get this idea that we're duplicating services of maybe the Department of Education or other federal entities. But what we do believe is that, as you're aware, NASA has and is unmatched in the federal government in its ability to inspire young folks and change lives and create the next generation of scientists and engineers. Mm-hmm. NASA is exceptionally unique in that. And in fact, you mentioned that you had folks, was it the University of West Virginia that are heading down to Houston? Yeah. So the University of West Virginia has done amazing things with robotic return capabilities, right. Which all those technologies are eventually going to be used for a robotic return of material from the Martian surface. Right. And if I remember right, University of West Virginia won a massive a prize, mm-hmm. and this was done by your students, a prize, right. Of course, that leads to more and greater technologies for that activity, and it was about $750,000. That's correct.
That's correct. And they are working on the West Virginia Robotic Technology Center.
Yes.
Is working on the Restore-L and working to refuel satellites in the low orbit. Let me just say, since I just have less than a minute, and I think I shared this with you when we talked, trying to inspire the next generation of young women, and particularly into the STEM area. I just want to thank NASA because Dr. Peggy Whitson came to 2 elementary schools with me, talked about her spacewalks, talks about how she's been in space longer than anybody else in the history, and she really inspired a lot of young girls that day, and that is such a rich resource. I mean, I was kind of standing there going, does anybody want to get in public service? And nobody would even look at me because they were just crazy to listen to what's it like to be in space and to get to be up close and personal with such an inspirational figure. So I hope that program continues, and I hope that the resources that you have there you share with the next generation to inspire. So thank you for that.
Yes, ma'am. Thank you. Mm-hmm.
Senator Van Hollen.
Thank you, Mr. Chairman. Administrator Bridenstine, welcome. And congratulations. And I appreciated the chance to get together with you again yesterday and go over some issues. And I want to thank you for the tone that you've taken ever since you were sworn in. And I do want to just underscore the comments of my colleague, Senator Schatz, with respect to your commitment to follow the science. And I think the employees at NASA appreciated the town hall meeting where you brought people together and committed to focusing on the mission. And I appreciate your enthusiasm and energy about the NASA mission, which is a great American success story and a success story for the world. And I do want to also underscore, I think, the importance of sending the message that we will focus on real science, not political science, including when it comes to recognizing that climate change is being driven primarily by carbon emissions generated by human activity. So I'm glad we're all focused on the science. And I also know that you were not responsible for the budget that was submitted. It was our former colleague in the House. We can all go talk to Mick Mulvaney at the Congressional Budget Office. But I do want to echo concerns that have been raised by all of our colleagues here on a bipartisan basis, and specifically with respect to some significant cuts in the earth sciences budget. Very proud of the fact that Maryland's home to NASA Goddard, and we also share with Virginia region and the Delaware region Wallops spaceflight facility. But on earth sciences, and you and I spoke about this yesterday, there's proposals to, really deep cuts, eliminate the PACE program and some other earth sciences programs. So if you could just again talk about what you see as the importance of those programs to the NASA mission.
Absolutely. So a couple of things that I think are important to make sure, because this is a bipartisan issue, and I want to keep it as bipartisan as we can possibly keep it. And it's important for our country. It's important for the world. The President's budget requests for 2019 on the earth science side of the ledger was higher than 3 of the previous administration's budgets for earth science. So, and it's tied with a 4th. So it's kind of right there in the middle historically of the last 9-10 years. So I think it's a good budget. And obviously, making difficult decisions in tough times, we made a determination that there were a couple of programs that ultimately were not the highest priority. It is absolutely important to me, as I know it's important to you, that NASA follows the guidance of the decadal survey. A brand new decadal survey came out in January of this year, and that decadal survey indicated that Clario and, as you mentioned, PACE are high priorities for the National Academy of Sciences that created the decadal survey. So that being the case, what we're doing right now within the Earth Science Division of the Science Mission Directorate is we are evaluating that decadal survey, trying to make sure that we're covering all the science that they have called for us to cover. And at the same time, because of what the Senate and the House did for the 2018 omnibus, we're moving forward with those programs. You mentioned PACE, I mentioned Clario. Right now, we're currently moving forward with those programs as required by the omnibus of 2018. So when we get to the point where we're ready to present how NASA sees the new decadal survey that recently came out, I'll be more than happy to come and brief you and make sure that we're all in agreement that we're getting the science necessary that the national academies have called for.
I appreciate that. And I'll probably submit for the record there are a number of other programs. Restore-L is one where NASA is sort of on a path-breaking mission for refueling. A number of other programs, including Discover. But if I could just use my remainder of the time to talk about Wallops, because I know you recently visited Wallops. If you could talk about why the Wallops flight facility is an important asset for NASA.
Well, absolutely. Just a few days ago, I was out there preceding a launch to the International Space Station from the Antares rocket and the Cygnus spacecraft that was resupplying the International Space Station. It's an amazing, critical, strategic asset for the United States of America. It helps us maintain our leadership in the world on the International Space Station with those critical resupply missions. And of course, there's a number of different sounding rockets that are launched from there for the purposes of weather research and climate research and a whole host of other capabilities. It is also true that there are a number of aircraft out there, former Navy aircraft. There's a P-3 that is importantly using LIDAR to measure how thick are the ice sheets in the Arctic or on the North Pole. In fact, just recently we had some amazingly brave pilots flying over the North Pole, flying over Greenland, over the North Atlantic, flying over Alaska, measuring the thickness of the ice using LIDAR, laser radar, if you will. And the capabilities that are coming from that, of course, are informing, helping us understand how the cryosphere is changing, the ice on the surface of the planet, and how that affects the rest of the planet. So those missions are important. We have NASA pilots that are taking great risk upon themselves to accomplish that science, and all of that is being done from Wallops. On the Restore L, if I have some time, I'd like to address that, if it's okay, Chairman. This is important. Robotic servicing for our country is a critical capability that we need to have for a whole host of strategic reasons. Very soon, a number of commercial satellite operators are going to be launching into low Earth orbit with thousands of satellites for communications. And historically, satellites, when they die, we either try to bring them out of orbit or we supersync them, meaning we put them into a very deep orbit that gets out of the way. If you're in geostationary orbit, we supersync them. In low Earth orbit, we try to bring them out of orbit. On top of all that, some satellites just don't work and they die. And then they become orbital debris, and we've had collisions, and we've had reports that indicate that an Iridium Cosmos type collision that happened in 2009 that created 5,000 pieces of orbital debris. Those kind of collisions are going to continue to happen every 5 to 9 years. We have to make sure we don't do that. Orbital servicing of satellites, robotic servicing, is a critical capability. NASA is committed to it, and we want to make sure that we're doing it in a way that we can very dynamically and robustly service satellites in low Earth orbit to mitigate the orbital debris problem, keep our satellites on orbit longer, and make use of that capability. So you have a commitment from me that we will do that kind of activity.
Thank you. I look forward to working with you. Thank you, Mr. Chairman.
Thank you, Senator. I'm going to suggest a modified second round of questions. We have other senators who are expected to arrive. We welcome the senator from Alaska, but in the absence of a new arrival, those who are here or remain here will have additional questions till approximately 3:15 or so. So okay. I now recognize the senator from Alaska, Senator Murkowski.
Thank you, Mr. Chairman. I appreciate it. And Administrator, nice to see you.
Thank you.
I think you bring a refreshing view of expanding commercial space operations to the fore here, and look forward to having some conversations about what can be done to help lower costs, increase the capabilities for NASA by increasing some of the partnerships and utilizing more of the capabilities that are offered by the private sector for space access and operations. We have, in Alaska, as you know, some opportunities with the Pacific Spaceport Complex. In Kodiak, it's operated by the Alaska Aerospace Corporation. Can you share with me how you view the use or the potential of non-federal spaceports that can provide both the orbital and suborbital launch capabilities that may fit into future NASA programs and operations?
Yes, Senator. So NASA is committed to getting more science and more data than we've ever been able to get before, and we're able to do that now because there are commercial partners providing data in low Earth orbit, remote sensing and imagery, as well as communication. All kinds of different sensors are being launched commercially to provide all kinds of capabilities that really have nothing to do with NASA specifically. But what that means is that we have the ability as an agency to purchase commercially access to space and to purchase commercially data from other people that are accessing space for other reasons. So the way I see it, ma'am, going forward is the miniaturization of electronics, the reusability of rockets. We're going to see unprecedented access to space in the coming years. And a facility like Kodiak, of course, is going to be a beneficiary of that capability. So as an agency, what we don't do is when we want to launch commercially, and we are going to be launching commercially, and we do launch commercially, a whole host of small satellites to do science, and of course even universities are building satellites on our behest. And the more we do that kind of activity, the better data, the more data we're going to receive. What we don't do is we don't tell our partners where to launch from,
Right.
but a healthy small launch market, medium class launch market is what we want as a nation strategically, beyond just NASA, but for our nation strategically. And of course, Kodiak could be a great player in that.
Well, you mentioned there's a lot of potential, I think we recognize out there, and these emerging, the small launch vehicle operators have some great opportunity, I think, to expand our space launch market and bring back some of that launch business that we've been seeing overseas. So hopefully you share that same view of opportunity for how we might proceed with that. Let me ask about your plans, if any, to work with federal and non-federal entities to help streamline the satellite regulations and the launches that would help provide and improve broadband infrastructure for rural areas. This is, of course, a great interest to us up in the north, and particularly the high north. We see this as that opportunity that will really help build out our capacity in some of these very remote, rural, and high-cost areas. Can you speak to that?
Absolutely. It'd be my honor to speak to it. So historically, when you talk about communications from space, historically it's been done from geostationary orbit. So when you think about DirecTV and Dish Network, even some communication satellites for internet from space, for example, that's done from geostationary orbit, which is 33,000 kilometers from Earth. It's the highest orbit. The upside is that they don't move relative to the moving of the Earth. As the Earth turns, they stay in the same position over the Earth. So that's the upside. The downside is that there's latency. There's a time for the signal to travel all the way out to geostationary orbit and all the way back. So what's happening now that I think a lot of us, and I know you're excited about, is the idea that we've got antennas now that are electronically steerable, which means a flat antenna like this notepad would be on somebody's house, and in low Earth orbit, where the satellites are constantly coming over the horizon, and you can't just have your satellite dish locked to one satellite. You've got to be tracking one satellite and sharing information back and forth with that satellite, and other satellites are coming by. You have to be able to pick those up. So electronically steerable satellite antennas are a huge technology breakthrough that are now being commercialized, which enables us to do this. Take those satellites in geostationary orbit and bring them down to low Earth orbit. Now, this isn't necessarily tied to NASA, but it is tied to a robust commercial marketplace for communications, to the point where if we can get it down to low Earth orbit, these constellations of thousands of satellites in low Earth orbit, the latency goes down to the point where you can use the exact same kind of waveforms as a cell phone. And so now we've got potentially thousands of cell towers in low Earth orbit that any of us can access, and you can have portable bandwidth that can be, if there's 100,000 people descending on one part of the country, maybe there's a convention in Anchorage or something, you can steer the bandwidth to make sure that nobody gets blocked out from being able to use their cell phone. So this changes how we understand communications on planet Earth. I, for example, could be on an aircraft carrier, which I have been, in the middle of the Pacific Ocean with no access to any kind of internet connectivity. And all of a sudden, if these kind of constellations get built, I would have access immediately, instantaneously. So that's transformative. Obviously, in rural Alaska, that's a big game changer.
Game changer.
Absolutely a game changer. So it's a game changer for a lot of my old constituents in Oklahoma, for example. To what Senator Van Hollen was talking about with robotic servicing, that's the capability where those satellites in low Earth orbit with a robust commercial robotic servicing capability, those satellites in low Earth orbit, they would generally come out of orbit, in 5 to 10 years, just because there's trace atmosphere in those low Earth orbits. But with robotic servicing, you can boost the satellites. You can even change the technology on the satellites to increase capacity and throughput to get more data than we've ever gotten before. And of course, data rates are continuing to increase. It's all about getting more gigabits per second of throughput. So there are a lot of opportunities here, and NASA wants to be a partner. That's why robotic servicing is so important, and we intend to do that.
Exciting. Thank you, Mr. Chairman.
Thank you, Senator. Administrator, we talked about, a number of us has raised the topic of education. Let me take this to the university level, but let me do that by talking a moment about the aeronautics aspect of NASA. NASA, for example, is currently working on a low sonic boom aircraft that's expected to shorten flight times across the country and to destinations around the world. Research is done with the FAA on traffic management, on integration of piloted and unpiloted vehicles into the nation's airspace. Advanced material developments and characterization will lead to safer, cleaner, more fuel-efficient aircraft. Kansas, as you know, Oklahoma as well, is an aircraft aviation. We are states that in many ways dominates what we do for a living. I want to know your view as to the role that universities can play in being a partner with NASA in regard to aeronautics. What do you expect to happen, and how can I be of help to you in that regard?
That's another wonderful question. We see universities as a great opportunity to help us do the research necessary to get more advanced materials, composites, for example. And I know Kansas, you guys in Kansas are really big into composite repair and composite manufacturing. I know the Aeronautics Mission Director, the Aeronautics Research Mission Directorate at NASA is working through an advanced composite program with, I think it's the University of Wichita, in conjunction with Spirit Aerosystems, to put together a consortium of, research, which is the university, and manufacturing, which is Spirit Aerosystems. And that kind of partnership, along with NASA's, some of our, brilliant engineers, puts together really an ability for us to stay ahead technologically when it comes to manufacturing aircraft and creating lighter materials, materials that ultimately increase fuel efficiency and improve aviation in our country and make us more competitive in the world. So I think that partnership is solid. I think we need to do more of that kind of activity, and I support it.
I appreciate your answer. Let me turn to, as I arrived in this position to chair this subcommittee, one of the things that captured my attention and somewhat my imagination is the Webb telescope. And it's had its challenges. I'm interested in knowing what you see as its history, but more importantly, what you see as its future. There's been a lot of attention paid to it by Congress, by GAO, by the contractor. What do you see forthcoming, despite some of the challenges that the telescope has had?
Yes, Chairman, it's a challenge that we have. I want to start by saying this, and I believe this, with James Webb Space Telescope and other things that NASA does. This is what we ought to be doing, is staying at the very leading edge of technology. When the James Webb Space Telescope launches, it is going to see back to the beginning of the universe, and that is an amazing capability that all of us are anxiously anticipating. That being said, as important as that mission is, as critical as it is to NASA and to the United States and to the world, as critical as it has had its challenges because we are at that very leading edge of technology. The impact, of course, there's been a number of challenges. You start with the fact that the thrusters were one of the issues that we had. The thrusters were cleaned with a solvent that was not the right solvent, and that damaged some of the seals that ultimately required us to go back and develop new thrusters, to build new thrusters and fix thrusters. That set us back. The sun shield that was on it, the ability to unfold it and fold it back together and test it, that has proven more challenging than I think was anticipated, and that has set us back in terms of time and budget. We are with our challenges with the James Webb Space Telescope. What I will tell you this is, looking at the impact for 2019, the budget for 2019, I don't think the impact is going to be that significant, and here's why. Because instead of doing operations, which we have a budget for operations for James Webb, we'll just use that operations budget for development. That's not a good thing. I'd rather be using it for operations. But the reality is, for the 2019 budget, I don't think it will be that big of an impact. I don't think it will be that big of an impact for 2020 for that same reason. The biggest challenge that I have, sir, and I'm probably going to have to come back and talk to you, there's a potential, I don't want to get ahead of myself because I don't know yet, but there is a potential I might need to come back and talk to you, is that there is a funding limit on the James Webb Space Telescope that's set at $8 billion. And if the development costs go beyond that, we're going to have to come back to Congress and get reauthorized to continue the mission. I would say that at this point, we have spent so much money, and we have come so far, and we are so close, that it's important that we do that. And I will testify to that today, but I'm here to tell you that I don't know if we're going to hit that $8 billion mark or not. I honestly don't know that. The good thing is we have an independent review that's underway right now by a person who is exceptionally good at this kind of activity, and he and his team are going to report to us and to you on the status of the James Webb here in June. And when that report comes out, we are going to have to come to a meeting of the minds and figure out how do we go forward with this program, if indeed we do need to go above the $8 billion cap that was set by Congress.
Thank you for your testimony. Senator Van Hollen?
Well, thank you, Mr. Chairman. I was just checking off one of my questions on the Webb telescope, and we talked about that when we met yesterday,
yes, sir.
Mr. Administrator. And you're right, we've had some setbacks. I hope the independent review gets to the bottom of that. But as I understand your testimony, you're 100% committed to getting this program to completion and fulfilling the mission. Is that right?
Without question.
Thanks. The other question I had related to one of the recommendations that came out of the decadal survey. You mentioned the importance of pursuing the recommendations, and we talked about this a little bit yesterday. And the top priority large project in the 2010 National Research Council's decadal survey of astronomy and astrophysics was the Wide Field Infrared Survey Telescope, WFIRST.
Yes.
Could you just talk a little bit about why the decadal survey made that a priority and the importance of that mission?
Absolutely. So when we think about these big projects like the James Webb Space Telescope and the WFIRST Space Telescope, these are opportunities for us. We're talking about programs that have a finite lifetime. So when the end of the James Webb happens, we need to have something that can come next, and that something needs to push the edge just a little bit further than the previous. Now, I certainly understand all of that. One of the challenges we have is because of when we do these flagship programs that take a big chunk of what the decadal survey is wanting in terms of science. And if you take 60% of the budget that we have to do one particular mission, and then that mission grows, that puts us in a really difficult spot for all of our other missions. And so when we think about WFIRST, first of all, we are following through on the omnibus of 2018. That's happening right now. And we are looking at what the costs are going to be going forward for WFIRST, and we're committed to not have the same thing happen to WFIRST that happened to James Webb. So that's where we are on that going forward. When we think about decadal surveys in the future, we might want to consider maybe distributing the risk among more smaller projects rather than one massive project that can clobber an entire division within the NASA budget.
Got it. I look forward to continuing the conversation. Thank you.
Yes,
Thank
sir.
you, Mr. Chairman.
Senator, thank you. Senator Schatz, thanks for filling the role of ranking member today. And Administrator Bridenstine, thank you very much for your testimony. Our votes have been called. And I would ask you, if you have a moment after the hearing, I would like to spend a minute with you.
Yes, sir.
And I would announce that our subcommittee will have its markup at 2:30 on June the 12th. That will include NASA, but our full array of issues within our subcommittee's jurisdiction. 2 days later, June the 14th, the full committee is scheduled to meet to do markup of this and other appropriation bills. With that, there are no further questions this afternoon. Senators may submit additional questions for subcommittee's official hearing record. We request that NASA respond to those questions within 30 days. The subcommittee now stands in recess, subject to the call of the chair. Is that the right word?